to start to talk to you about something called two-variable data. And if you think about all the videos we've watched so far, all the lessons we've done in class, Chapter 1 and Chapter 2 were dedicated to studying, right, one variable at a time. And then we described the distribution at one variable. We talked about density curves and normal distributions and all kinds of things like that. But today starts the beginning of Chapter 3, where we're going to compare two variables and see maybe if there's a relationship between the two. So just look at this first example. The university would like to construct a mathematical model to predict the first-year marks for incoming students based on their achievement in grade 12. And here you go. Here's the chart. So this first data point you see here is telling me that here's a person who got an 85 as an average in 12th grade, and the first-year average at college was a 74. Okay. And the second data point is telling me that a person with an average of 90 in 12th grade got a first-year average in college of 83. Okay? So what you might be interested in is, are these two variables related? And when I say that, does that mean as one increases, does the other one increase? Like they increase together. Or maybe if one increases, the other goes down. So these are the kinds of things that we're going to concern ourselves with. And then also, we're going to want to know which variable do you think is affecting the other one? Okay? So I'm going to start with that. If one of these variables is sort of having an effect on the other. So I'm going to introduce you some new terminology, something called an explanatory variable and a response variable. Okay? So a response variable measures an outcome, okay, of a study. Okay, so that's one thing. There's also something called an explanatory variable. So an explanatory variable helps explain or influence the response variable. So what I'm going to say is every time you look at a set of two-variable data, you should ask yourself which one of these variables might be the response variable and which one might be the explanatory variable. In other words, which variable is causing the other one to change or react. All right, so when you're going to investigate the relation between variables, that's one of the best tools to start with is something called a scatter plot. Okay? And a scatter plot simply shows the relationship between two quantitative variables. So let me show you how we're going to do that. We go to our calculator, and we have to get this data into the calculator. So you usually press Stat Edit. You're not already there. And you can tell that I have this data in List 2 and List 3. So List 2 is the average that they had in 12th grade, and List 3 is their average for their first year in college. Okay? And what we're going to do is we're going to create a new kind of plot. All right, so first off, make sure you go to y equals and just check, make sure there's nothing there. I have an equation here, so I'm going to clear it out. You should do the same thing. Sometimes these things show up, and it's not good to look at. Do second y equals after doing that, and we're going to go to plot 1. Make sure it's on. And then when you go down, you're going to select that first type of plot. It looks like a bunch of dots. It's called a scatter plot. Okay? What really we're going to do is graph x comma y, where x is going to be the 12th grade average, and y is going to be the first year college average. You go down. Now, you know where you put your x lists. I put mine in L2, and I put my y list in L3. Okay? And then the last thing is the type of mark you would like to use. I'm going to use a plus sign. I have that highlighted. Once you've done all that, you can press Zoom 9, and you'll get this picture. All right, so let's make sure we know everything is. On our horizontal axis, x, that's usually our explanatory variable. And the the variable over here, y, is our response variable. Okay. So when you look at a scatter plot, there's a few things that you want to pay attention to and sort of talk about. One, you should talk about the direction of the relationship. When we talk about direction, we could think of this a couple of ways. You could think of it as, is the graph increasing or decreasing? Or sometimes we say, is the graph or is the relationship positively associated? Or negatively associated? So if you look at this picture, here's what we can definitely say. We can say that generally, as x goes up, y goes up. All right? You can confirm this is positively associated by thinking about slope. If you look at this data, the general trend of it seems to be as x gets bigger, y gets bigger. If you think about slope, which is change in y over change in x, well, what are we saying? We're saying y is going up over x is going up. Well, that's equal to some kind of positive number. So if you think about slope, slope can help you out in determining the direction of the relationship. Okay? The next thing I want you to do or think about is the form of the relationship. So for the form of the relationship, for the time being, we're just going to answer this question. Is it linear or not? So we take a look at the graph, and we look at the trend, and we say, does it look like these data points sort of line up along a line? Okay? In this case, I would say yes. There is sort of one point that might not be so great, but if you look at it, generally, it looks like maybe that. Looks like it lines up like a line. So I would simply say, yes, this is linear. Okay, and then the final thing I would address is the strength of the relationship. So if you think it's linear, how closely packed around the line do you think your data points are? So that might be subjective. Some people might look at this and think, I think it's weak linear. Okay, I would call this moderate to strong, believe it or not. That's what I would say about this relationship. This relationship is moderate to strong. Okay? And those are the three things you should always address when you look at a scatter plot. Is direction, form, and strength, always. And like I said, for the time being, form is only going to be linear or not. In the future, we'll talk about other forms. Okay, let's see what else we can gather from this scatter plot. There's one point up here I'm kind of interested in. And the question I want you to think about is, what do we know about this person? So we could say is this is a person who did better than they expected, or better than we would have predicted based on this sort of line that describes the trend of the data. Okay? Next, what we're going to do is we're going to be a little bit more precise about this line that we are putting on the graph. Okay? A little bit more precise about it. There's a way to get the line that best describes the data. And what you should do to get it is the following. You look at all your data points, and I want you to draw an ellipse around them. An ellipse is like a jelly bean. Okay? That catches almost all the points, catches most of them. Notice the outlier point I didn't quite catch, but that's kind of far away from the other data. You know, I made my ellipse go close to it, but I didn't worry about catching it. Okay? And what you do next is this. After you've made your ellipse, we go to each end of the ellipse. So I'm going to go on the left end here, and I'm going to pick the point where I think a vertical line would come by and just touch the end of the ellipse. It's sometimes referred to as a tangent line. You may have heard that language before. Okay? So like I said, this kind of line is called a tangent line. And then what I'm going to do is I'm going to go to the other side of the ellipse, and the same thing. I'm going to draw another place where I think a vertical tangent line would be. So there's another one. Okay? And what I'm going to pay attention to is the points where the tangents touch the ellipse. So there's a point here where the tangents touch the ellipse, and another point here where the tangents touch the ellipse. And it turns out that those are the 2 points you want to go through to create this line of best fit, as it's called. So draw a line through those 2 points, and this line is called the line of best fit. Later on in the course, or like in pretty shortly, we'll call it the least squares regression line. Okay, now we don't know what b squared means yet. We're not going to know that yet. We'll wait on that. But for now, we can call it the line of best fit. The reason I kind of like having this line here is because lines have slopes. So you can see right on this graph, look, delta x here, delta y here. Okay, and you can tell in this case that delta y over delta x is greater than 0, which proves or confirms that we thought this thing was positively associated. Okay? All right. Well, it turns out the calculator can do a very good job at giving you this line of best fit, and that's what we're going to show how to do now. So we're going to go back to our calculator, and we're going to press stat. And we're going to go to the right to calculate, and we're going to go down to number 8. And you may have seen this before. Oops, I could just press the number 8. But there it is, LinReg, stands for linear regression, which you may have done in earlier courses, is a plus bx. Hit enter, okay? And depending on the version of the x84 you have, you might see something different. Some of you see something that says X list, Y list, frequency list, store, regression, EQ. If you have that, you can just put the things in the right place. For people who have a calculator like this, which doesn't have that nice menu, what we're going to do is we're going to do second and L2. I'm picking second 2 because that's where my X values were. They were in list 2. If you have the other kind of calculator, just put your X list where it says X list. Not yet. Press comma. And now I need to tell it where Y is. Well, Y is in L3, in my case. In your case, it's someplace else. And then lastly, what I'd like to do is tell the calculator to take the regression line and put it into Y1. So to do that, I hit comma one more time. And then I press a button called vars. Right on the front of the calculator, next to clear, to the left of it is a button called vars. Press that. And then it says vars and Y vars. I want to go to Y vars, so I hit the right arrow. It says function. That's perfect. I hit enter one time. It says Y1. That's perfect too. I hit enter. And the calculator will give me an output. Okay, I actually have to enter one more time. Here it is. And you'll see this information. Now, some of you may see R squared and R on the calculator. The calculator's not set up to do this right now, so don't worry about it. What you'll notice here is that in Y1, I have my equation. There it is. 22.475 plus 1.168x. I'm going to make a note of that. So our equation looks like y equals 22.475 plus 1.168x. Now, one little piece of notation. Make sure over the y you put a little thing that looks like that. Okay? That stands for, we read that as y hat. That's how it's read. So I'll say that a lot. I'll say y hat. And what y hat means is that you have a regression equation. It means it's an estimate, okay, for the exact y values on the graph. Doesn't mean they're necessarily the exact y values. Okay. Okay, I made a mistake. This should have been negative. Sorry about that. Okay. So let's take a look at this equation because there's a lot of information hiding here, and it's sort of fun to ask about it. So I'm going to start by looking at the slope. Okay, there it is. That's the slope. Now, that slope has a denominator. Even though you don't see it, you know the denominator is 1. It's just not written there. So I'm going to write m equals 1. Actually, the notation in the calculator said b. So I'm going to say b equals 1.168 over 1. And now would be a good time to ask what the meaning of that slope is. Okay, and to do that correctly, what you should do is think about how slope is. It's delta y over delta x. The units on x, or what x was measuring, was the 12th grade average. And then this number on top was measuring the first year college average. So once you write slope like this over 1 or as a fraction and you label things with units, you can write a very nice sentence. You can say the following. As, or I can say it this way, if the 12th grade average increases by 1, then we can expect the first year college average to increase by 1.168. And in all of these questions, it makes sense to just ask yourself about slope, figure out what it's telling you. This confirms the positive association again, because we're seeing x increase, and then we know exactly what increase of y to expect. So the regression line confirmed what we thought. I'll say this. Sometimes it's interesting to look at the y-intercept, but in this case, maybe not. So the y-intercept here is, there it is. It's negative 22.475. And in some questions you'll be asked, what does the y-intercept mean? Well, if we're talking about a y-intercept, we automatically know that that means that x must be 0. Because the only way you can cross the y-axis is x is 0. So the y-intercept in this case means that if my 12th grade average was a 0, then I could expect my average for my first year of college to be negative 22.475. That doesn't really make any sense. So I will tell you that sometimes lines of regression, like especially the y-intercepts, might not make a lot of sense in the context of the problem. Okay? But you should always be prepared to try and interpret them. The best way to interpret them is to just think, okay, what does x represent? X is 0. What y value goes with x is 0? Okay?